Welcome to the stream, guys. We are going to create a very simple game that is a very old Commodore 64 game that was called Nebulus. YouTube Nebulus 64, and this is the game. You have a simple character on a tower, you move. It's just a simple platform. So, stop and create our new project. Will be 2D, and I'm going to use this version, 2020.3. 2D, and let's call it Nebulus. Great project. This will take a few seconds to start for me. I already created, just to find where I placed it, a folder with all the images that we are going to use. I did a zip of this folder and shared, and I will share it again later. So this is our Unity, empty right now. Let's go on the scene and just rename the scene here, Nebulus, and reload. Control S, and we are ready to start. So first of all, let's do the player. We create a folder, player. We go inside, and I'm going to drag and drop the images here for the player. Unity, folder. This is the player sprite. As you can see, this one is a multiple sprite inside. We are selecting the object and say that its sprite mode is multiple. Pixel per units here is 64. Click on apply, go in sprite editor. You see all the sprites. We are slicing in the single images. Click on slice. Method will be by cell count. Those are 8 by 8, not everything a field. And by doing this, we already got our player sprites available. Close that. If you open this now, you will see all the single images. Just drag and drop this inside the scene and rename this to player. And this will be our main player. Very simple. Now, reset the transform. Let me also disable the gizmos here. We don't need them right now. First thing that we will do is just to create an walk static, an idle and an walk animation. To do this, you select your player, you open the animation window. This can be opened in Window, Animation, Animation. I already opened it and placed it here. You select your player. For the animation, you click on Create. Then you select the path. I'm playing it directly inside the player, and I will call it Stay Animation. This will be the idle. Click on Save. And here, we are just going to drag and drop the sprite. You can expand it to see it. This animation will be just a single frame, doesn't really need more than a single frame. It will be a completely static, no animation. You do this, and you can see the animator window. Animation is to create the frames, animator is to see the events. For example, there will be as default event, the sprite will stay. Let's do the walk animation. You select your player, you go in animation. On the drop down here, you can click and create a new clip. we call it walk. And inside, I'm going to place those sprites here. From 1 to 6. Drag and drop. Let's make it a little bit more open. And let's try to make exactly the same timing each step. When you do an animation like this, let me play it to show you. This will, as you can see at the very end, looks like it's skipping a frame. Why this? Because this frame here will last just a frame. It should last for the same amount of time of the other. To do this, you re-add the first frame at the end. This is something very common for sprite animations. If we play it now, you will see that it's more fluid. Okay? So, this is our walk animation. If we go in the animator, we will see that we got the animation. And we will control it by adding a parameter to our animation. Parameter will be just a status, so we are going to use an int to set the status. We'll call it move. And we are going to define the transitions. So if this value is 0, we stay on the animation stay. If it is going to 1, we are going to walk. To create this, right-click on the source, click on Make Transition, click on the destination. Select the arrow. Here you get conditions. Click on plus. You already have your parameter move, is the only one. And we'll say if it is equal to 1, we move in the walk. We do the same going back. So if we are in the walk status, we make a transition to go on the stay. We select it. We add the condition, move equal to 0, we go back to stay. So if the move will be 0, we go on stay. If move will be 1, we go on walk. Now, because those are sprite animation, usually we do not want any transition between them. To remove them, we can just place everything to 0 here and disable. Transition is good if you are animating properties or 3D objects, but with sprites you don't really want to blend because there is no real blending between sprites. So we did this. We got now inside your assets the player, animator, stay and walk. Very simple. Let's go back on the scene. We have just the player. Let's create our game controller. I'm creating an empty object. I call it game. I place the player inside the scene. Let me drag it outside. Okay. And here I'm going to create at the root another script. I will call it game. Okay, let's double click on game to open the Visual Studio. First, let me drag and drop the game script inside the game object. Double click and Visual Studio starting. So let me just clean up everything from here. I prefer to keep it as simple as possible. Let me do some zoom so you can see it right. And let's do some movement here in the update. So void update. We'll use float x equal input get axis horizontal. This game you just move left and right and jump is not nothing else you can do. with this one, we'll get inside this value -1 if we are going left, +1 if we are going right, and 0 if we are not moving. We are going to grab a reference to the player, to the animator of the player, to handle his animation. And to do this, we will do public animator, and we'll call it just anim. Now, what is this animator? Let me go back to Unity. If I select the player that we created before, we created the animation. This one added the animator component to the player. This is used to play the animations. Inside the game, the public will make this visible in the inspector. You can use private, serialized field, and so on. As a public is just faster for this small example. We will just drag and drop the player inside to link to the animator. Now, let's go back to Visual Studio, and we will do if x less than 0, we will do something. Else, if greater than 0, we will do something else. Else, if you are 0, we will do the last part. First of all, we are going to flip left and right if we go on left and right. To flip a sprite, let me go on our player, we can use the sprite renderer of the player. There is a property called flip that, if it is checked, will just switch the object left and right. You can switch it also up and down and for other cases. We just want to flip X and Y for us. So let's do a reference to this sprite renderer. And this will be another public sprite renderer player SR. And here we say if x is less than 0, so we're going left, we want to flip it. So player SR dot flip x true. This is enough to flip it. If we go on the right, we don't want to flip it, so same but with false. And if we are not moving, we will remain in our direction. Let's save. Let's go back to Unity. Let's select the game. Let's fill the player sprite renderer with a drag and drop. If now we click on play, if I click left or right, we are just switching the player. Let's do also the animation now. It's pretty much the same code. If we are moving, I will call anim and I will alter our parameter. So set integer move to 1. I will do this if I'm going left. I do this if I'm going right. But I will set it to 0 if we are not moving. Let's have a look. Play. Can you mute yourself, please?
Lona, can you mute yourself?
Okay, let's try. Let me go on the right. I release, and the sprite stops. I go on the left. So with 10 lines of code and a very simple animation, we already create the walk animation. Any question on this subject? Is this simple enough?
Yeah, it's simple.
Okay. Now, let's start to create our world. In the original game, the world is pretty much just a tower. We can create this with just a cylinder. This game will have just the player that is 2-dimension, but everything else will be 3-dimensional game. We do a right click in our scene, 3D object, and we'll use a cylinder. Let me enable the gizmos so we can better see the items. Let me...
If you, one question.
Yes, ask.
Okay. So, are you starting from scratch this project?
Yes.
Okay. Okay.
The only thing I already did are some images, just because doing in real time the images takes too much time.
Okay. Okay.
But yes, everything is from scratch.
Okay.
Okay, so we created our cylinder. Right now is just an item here. Let me create a folder inside the assets. Create folder statics. And let me create just a basic material, tower. And right now just me pick a color, nothing special. Drag and drop on the cylinder to change the color. Rename this to tower. And let me disable the camera because I don't want to see the camera here. Okay. Now, what is our player? Is behind the camera. Let's go in 3D. Let's go from the top. Our player is here. We want to move it outside. So let's say -4. And the tower, we want it a little bit bigger. So let's try with 4 by 4. Oops. By 4, maybe 6, maybe 8. Yeah, 8 seems to be big enough. But we need to move the player a little bit more. Let's go back into the... Yes, it looks good enough as sides. This is what will the user will see on the game. But we want it to be way taller. So let's go in tower again. And let's put this as 20, maybe. Let's see if it is big enough. This will be very big as tower. Now, let's move it a little bit to the top. Something like this. I love integer numbers. And let's move the player a little bit down. For example, like this. Just -1. Yeah, something like this. Now, if I go in 3D mode, you will see that we got this super big cylinder with the sprite just in front of it. That is exactly what the game will be. But an object like this is completely flat. So let's add some texture to the object. Let me go in my texture folder and I will grab the wall texture. I go on the tower and I will just use this as albedo. I will go back on white as main color. Now this is, as you can see, is strange, is dark. This is because we did not define a light right now. So let me just disable this for a moment and then we are going to create a light. If you look here, this texture is very big. One thing we can do here is to change the tiling of the texture. To do this, we have to select our image for the texture, go in wrap mode and set it to repeat. Click on apply, nothing will happen right now. But if we go now on the material, we can use the tiling values to replicate the texture. If I click on 2, this increase, 3, 4, 5. Let's use about 10 of them and do the same vertical. And now we have just to find a good value for this. Maybe something like this, a little bit more. Yeah, this looks like a tower to me. Okay, look.
Do you gonna use some shader, the legacy shader?
Not for this object. This object surface shader is fine. I will use a legacy shader for another type of objects because I need transparency, and standard shader do not support transparency. But for this object that has no holes is fine, the standard shader. Let's add the light. We can place a light where the camera is. To do this is better to look at from the top. We select our camera and we can place the light somewhere here. So right click, light, directional light, and let's try to move it, and let's see how it is. Of course, I have to enable lighting, and this light looks okay to give some.
It's the directional light.
Just right click on the object and then light, directional. Then on directional light you have to place it like on all the objects, and then you can rotate the light to understand where the lights will go. Okay? Now, this one looks okay. In the game, the player will always stay in the center of the screen without going left or right, but the tower will rotate. Now, the tower is a cylinder. If we go on the tower itself and we will change the rotation, the y-axis, that is vertical, looks what will happen. So we can rotate the tower at 0 cost, because literally it costs 0 for us to do this rotation. Let's get a reference to the tower in our game code. That is just a transform, public transform tower. And let's do some movement here. We are just going to change the rotation. So tower rotation equal. Yes.
What question? Are you using intelligence for specific unity? Because it's getting you like references when you type tower, it's showing how it would get components, everything before you even type.
There are two things you have to do. One, in Unity, you have to be sure that in your project preferences, let me move it this, you go in an external tool, you are sure your Visual Studio is connected, and you click on regenerate project files at least once.
Okay.
But also keep in mind that my Visual Studio is Visual Studio Enterprise, so I got some benefits from this tool. Yes.
Okay, you bought it, this one.
Yes, of course.
Oh.
But also on community works, you get less advice, but you still get the code completion when you want. So to do the rotation, we can, let's do first an immediate rotation. This will be just a quaternion, Euler angles, x will be 0. The horizontal is going to change. Let me put a variable here, and the x will do nothing. Now, what this can be? This can be the current rotation y. So rotation Euler angles y minus some rotation speed. That this is a variable we're going to define. Public float rotation speed 25. We add that header. No header. And we do the same on the x, but in the opposite direction. Right now I'm just replacing immediately this every frame. Let's have a look. But of course will not be very good. Oh, sorry, look the error. I forgot to assign the object. Game tower. And let's try again. As you can see, yes, it's rotating, but that's very bad. Why? Because we are not interpolating. We should do something called lerp. So quaternion slurp from the current rotation to this rotation we defined as time delta time. Let me copy this because it's the same, but I need plus here. Let's try again. And the rotation now, I think, is good. What do you think?
It's good.
Yeah, it's
Fine.
Great.
Okay. Now, let's do some simple water on the bottom. We will do it very, very simple this time. First, we're going to create a sprite, square. We'll call it water. And we'll just define a basic color to it. Now, give me a moment in 3D because I have to place this correctly. And also, let me disable this for a moment. Okay, so water has to go like this and way bigger. Oops. Let me see if this is big enough. No, let's do bigger, more. Okay, and let's use a normal water color like this. Maybe a little bit darker. Okay. Now, if we go back into D, this water will be not visible. Why? Because it's a sprite and it's completely horizontal. So, sorry, not very visible. Let me also be sure I placed it. I also place it upside down. Okay. More or less to the bottom of the object. What can we do? We can either rotate this item like this, either we can move the camera a little bit down. Do you see? Either are good. We can do either meter to adjust. Yesterday we moved the water, but I think moving a little bit, just a few degrees, the camera is a better result on the full game. So let me make this even bigger because it has to go to the objects. and let's be sure it is visible in the camera view, because right now it's clipping. I'm placing one on the side of the other just to have a good preview of what I'm doing here. Something like this looks okay. Okay, we did this water here. Let me create a folder. But it is static and nobody wants static water. So let me grab some images I prepared. And let me create 3 sprites inside. We'll just duplicate the sprite 3 times. And I will change to white again and place those items. White. Okay, and they're quite big for some reason. Let me have a look to why those are so big now. For some reason they are huge. Well, let me do this one. Okay, and let me scale this to something more appropriate. Something like this. Okay, now let me go back here. Let me make them a little bit transparent, actually a lot transparent. And this one for some reason is still not good. Let me do it in a different way. Duplicate this, set it as 0, full blue color, no alpha, and make it to the bottom, and we'll remove this sprite render here. Now let's change the orders. This will be 0, this will be 1, this will be 2, and this will be 3. As you can see, looks like some water. The problem is that now this is completely static. So what can we do? We can move it using some function to go left and right. Something like this. Okay. We will create a small script here. Call it water. And inside we're going to put a reference to the 3 transforms. Public transform water layers, void update. What are we going to do? We're going to move left and right with the sinus function, the water. Let me do it with just one layer, very simple, and then I will show you how we can improve this with some math. Sine time delta time, multiplied a small number because we don't want to move it too fast, plus some offset, just say 1, multiplied how much do we want to move, let's say 2. I need to do a vector, vector 3 position, equal vector 3 0 position dot x equal this, and then we will reset the position here. Let me go to Unity. Let me set on the script water. Okay. And in water layers, I will just place water 1, 1, 2, and 3. If I play, let's play like this. You will see that the layer should move a little, but probably I did an error. Water won't transform. That's okay, because position is -5 here. Okay. 0. No, this one is okay. -5. That's okay. This is okay. This is okay. Ah, delta time. Yeah. Sorry. This is time, not delta time. My bad. As you can see, it is moving a little bit. You see it?
Yes.
Okay. Now, it's on a vertical strange position, and I don't know why, because because it's not position, it's local position. Okay, and let's do the same for all three. 1 and 2. Let's add some parameters here. So, range, let's go from .1 to 2. Public float speed 0. Speed 1, speed 2. Some offset and some size. And we will change this to speed, offset, size, copy, paste, and then just set the different numbers here. This is just to do some fast coding here. This will be all 0, but let's have a check on those values. Just placing something random right now here. Let's play and let's have a look how it works. Do you see it?
Yeah.
And this is very simple to create some simulated water with literally 3 lines of code.
I think the size should be increased.
What should be increased? Sorry?
Like
the sides,
the
width?
Yes.
Yes, I
Like if
agree.
they go towards the right.
Yeah. I agree, because from time to time we see the items inside. Yes, I completely agree that. And so the scale here, x, let's do 4, no, 6. Yeah, this should be okay to understand. This should be okay to be always completely inside the game. Okay, that's good enough for
Yeah.
for the water.
Yeah.
Okay. Okay, so also the water is done. What can we do now? This is a
Platforms.
yes, this is a platform. We need some platforms here. To do the platform, first we are going to add to the player a rigid body. Just a normal rigid body. Also, with this a sprite, we are going to use a rigid body normal 3D because everything else will be 3D here. And I'm going to disable gravity right now, or we are going just to fall. I'm going also to add a sphere collider.
Constraints.
Constraints, yes, we're going to do them right now. Actually, I wish to show the error if we don't do the constraints here.
Yeah.
Yeah, this should be okay as sides.
Their collider was not very good yesterday, to be honest.
I don't get you. Say it again, please.
Because like if we were moving into the boxes or the platforms yesterday.
Do you think this has to be bigger, like 5, like this?
We can try with 5 today, I
Okay,
think.
okay, that's fine. That's fine. Okay, so we created the rigid body here. The platforms will be just a normal cube. Let me place it. Let's create a 3D object, cube. Let me call it platform. And this has already a box collider. That is fine. But we need a material to see it. So let me grab platform image. Let's create a material. Platform. With just drag and drop in the albedo and drag and drop material here. And now we resize it in as we want. So something like this, something like that. Okay. Let's go in 3D view, because here now we have a small problem. Placing those items here will be quite difficult because we need to create many. For example, I can let me just add a tag for the platforms because we are going to use it in a moment. Tags, new platform. Okay, added. And let's create a few of them. But as you can see, it's not very easy to place them. Yes, sure, I can rotate them manually. I go here and try to place them on the tower, but it's really time consuming to do this type of operation. But first of all, let's see if it is working. Now I place the platforms here. If I play, what will happen?
They
That
will not move.
the tower will rotate, but the platform will stay in place. Easy fix. We select them, we'll make them a child of the tower. If we do this, they will rotate with us quickly. Okay?
That's good.
Now, let's also enable now the player gravity. And let me move the player up, so it will fall on the platform. And what will happen? Oh, in this case it was not too bad, but here we have a problem. It was more interesting than yesterday. What we have to do, we have to lock the rigid body items. So we're going to keep the position horizontally, and we are going to freeze all possible rotations. If we do this,
Now it's not rotating and not falling down to the ground.
Yeah. Okay. So is working.
Why is it going inside the platform?
Yes, for some reason the collider seems to be not perfect. And
Collision detection continues.
no, I think it's just the collider that is maybe is not wrong. Good. Let me see. No, that's okay. We can try a collision continuous. No, is quite strange. This.
If we use 2D collider and 2D rigid body, will it work?
No, will not, because this is everything in 3D. With 2D colliders will be strange. But it's strange because yesterday was working fine. So there should be an error somewhere. I don't know.
Also, it was showing this error a bit less visible, but it was there.
But one thing we can do is to make the platform closer, because with the platform closer, this error will not be so visible. But I'm still not 100% sure, so let's have a... Yeah. Actually, I think it's a problem of speed, because if I move fast, I go up. If I move slow, I go inside. There will be an error we can debug, but let's not wait and waste too much time on this specific error right now. Okay, so we did those objects here. Nice, but if we want to do a full game like this, we're going to get mad in placing perfectly all the objects on the tower. So what can we do? We can create an editor to place the items for us automatically. How can we do this? First, we need to identify the tower as an object. To do this, we just create a script, nothing special. Tower. And the script can be completely empty. We really don't need anything inside the script. So just go here and clean it up. It's just as a reference, the script doesn't really need to have anything inside. But then we are going to create an editor. So we go inside Assets, we create a folder called Editor. Guys, this is important because whatever is in a folder called Editor at the root will not go in the final build. It's just for creating the objects. This is important when you are publishing a game. And we create another script. We will call it Tower Editor. Edit. Okay, Now here we need the Unity editor package, and this is not a mono behavior, but it is an editor, and we will link this to the tower we created by just giving the name of the script. And this is our body. Now there is a function we have to implement that is called onInspectorGuy. Override public void onInspectorGuy, and we do draw default inspector. This is just to see the normal inspector of the objects. If we do this right now, nothing will happen, nothing visible, because we go here and we see just the script for the tower, but nothing else. We also want to remove the capsule collider for the tower. We don't need it. Okay, so what are we going to do inside the tower editor? We're going to draw a button, and to do this we do something like if GUI layout button, the name of the button, let's call it align objects. And if we do this, we will call a function called align objects that we're going to define right away here. Void align objects, and inside right now just a debug log. Okay, what this will do? This will add a button with this name, and in case it is pressed, this function will be called. Let's go back in Unity and check. If we go to the tower, we have now this button, and if I go in the console and click the button, we get the message. So far so good. Let's go back here. What do we want to do here? First, we want to manipulate our object, that is the tower. So we will put a reference, tower, tower, and we need to grab it here. And we got something called target here, that is the current object. But we have to cast it to the correct type, that of course is tower. That is exactly the same item you do here. What we'll do here? First of all, whatever you do, you have we're going to inside all the children of the transform. So for each transform item in tower transform, this will go over all the children inside the tower. Before starting, we are setting the undo. This is important because if not, you will not be able to undo any change you do in the inspector. Set undo, and this is just a standard line from Unity. You can use it as is in all your projects. Undo, register, complete object undo. You pass the item, the object you are modifying, just a debug line, reposition object. This one is just to see in the undo list what the item is. Something like this. Okay, now first we have to find the position we want to align to. And this one is just the center of the tower, but at the same height of the current object. So vector 3, and this will be tower center, and this will be just the tower transform position. And we change the y, tower center dot y, to the same y of the current object. So item.y. Okay, now position.y. Now we are trying to place the objects at the correct distance. So first, place objects. We'll do a float distance, and I think it was 4.5 the correct value. We will see in a moment. And we are just checking where to place it. And we want to place it item.position on the center we calculated, so tower center, but we want to move outside of the distance we calculated. To move outside, we can create the distance vector, so is item position minus tower center. We normalize and we multiply by the distance. If we do this right now, let me move this in 3D so you can see better what is going on. If we go on the tower and click Align Objects, the distance of all the objects will be changed and they will be moved to the distance we defined. Okay? Let me see if the number we defined is good, but yes, I think the 4.5 is a very good number. Okay, distance is good and done, but we want also to rotate the objects to be facing to the tower. Let's add another couple of lines of code. Rotate. How we do the rotation? We need a function, a trigonometric function that is called arcotangent. It's just a function that will give you an angle from a position. It's very easy. Float angle equal is a math function, of course, and there is a common function for you here where we are going to get the item local position x and item local position z, and this is the angle we want to rotate, and we are just to set the rotation. Item.
We're gonna use a function called radius, I think. Radius.
Yes.
Mach. Okay.
Yes, we are going to use it. So I'm setting the angle here. Now, Euler angles want the value, as you can see, down in degrees, while this function here gives us the angle in radians. We have to transform it, and it's just a multiplication. Radian to degree is exactly what you need to convert from one to the other. Let's save. Let's go back to Unity. Let's click on our magic button, and all items are now well placed here. I can just go very quickly in moving them because they will be aligned automatically. Go here, click on tower, click on align buttons, and everything is aligned quickly for us. This very simple script is very powerful for us to do an easy creation of the world. Okay, so what next? Let me modify a little bit this item here. For example, I will place this here. This platform here is okay. This platform here, maybe I will place it here. And then another here. I fix. Little bit down.
So the distance you mentioned here, 4.5, is towards the tower, right?
Yes, is the distance from the center of the tower.
Okay.
I'll show you very quickly. I'll change this to 3.5. Probably will be enough to see a difference. If I click it again, they will go inside.
Yeah.
Yeah.
Makes sense.
And this distance will depend on the object. So later, depending on the type of object we are using, we will use a different distance. Because, for example, the door needs a different distance than the platform. Okay, so let's play a moment this game and let's see if it is good or not. So play, move, move, move. This one is okay, but if I try to go here, I fall in the water. We're going to add a jump function to move from, for example, jumping from here to here. So let's add a little bit of code in our game. We define first a variable. Public is jumping. Bool. And we will use the space key to jump. Get key down, key code space. If we click space and we are not jumping, we're going to do a jump in the game. So is jumping equal true, and we will add some force to the rigid body. We need a reference to the rigid body here. So let me duplicate the line, rigid body. Rigid body velocity equal vector 3 up multiplied jump force. And we will define also the jump force as variable. Not sure what will be a good value. Let's use 10 right now, and then we are going to change it. So right now, just basic jump here. Let's have a quick look. Of course, we need to. I will drag and drop the game on the very top because this is our main item to do all the game items. It's easier just to place a quick reference to it. Rigid body, go there. Let's play. Let's see if we jump. If I press space, yes, is a jump on steroids. We may need a little bit less power here. Let's try 5. Maybe 7. Okay. Now, jumping, we are jumping, but in our code, we never end the jump. When we have to end the jump, when we hit the ground, probably. So, to hit the ground, we can use on collision enter and check for platforms. but it's the player that will move. So we need to add a script to the player, very simple one. So let's go in player, let's create a script, player, drag and drop over the player. Okay. We get rid of all useless code. And we will use a reference to the game, public game, and we will use on collision enter. We're going to check if we hit a platform. So if collision dot collider dot compare tag platform, we go in the game and say is jumping false. Just this, super easy checking if we are hitting the platform on the player. Let's try if this works.
Why don't you make game a singleton?
Yes, we can do a game a singleton, but because it's referenced just in the player and not yet in other objects, we don't need it. When we will leave enemies, we might need to use it as singleton. But yes, we can do it. We just don't need it right now.
Okay, thanks.
You're welcome. Let's play. Let's jump one.
It will be a null reference. Okay.
Yes, we got a null reference.
Because we are not initializing the script, right?
That's correct. Okay, and yes, and now the jumping is good. And we can reach all those items. And this will be, if you want, Mario jumping, because we can change the direction while jumping. That is fine. It's just our decision.
Or we could restrict the jump as well, right? Like while jumping, we could restrict the movements on x-axis. You got my point?
I do not understand. Say it again, please.
I was saying that we could restrict the x movement while jumping. Like when the character is on the air, we could restrict the x and y because it was moving. When you jump, okay, just try to jump and then move.
Sure. Yes, it's intentional.
Yeah, this is the one.
The original game was allowing you to do this. You were able to move completely while jumping. It's just a game design, and for this example, yes, we will do a Mario jump that you can change the direction while jumping. Okay, so that's nice, but let's add a couple of animation for the jump. So we go on player, we create a new animation, call it jump up, and this will be the animation going up. There should be 7 and 8. So for a moment we do 7, and then we do 8 for about a second. And we will do another animation to go down. Create new clip, jump down, and in this case will be 9 and 10. 9, same as before. Okay, those two animations here that are in our animator, let me move this here, they will use they will use another values for the status. Still the movement is okay, but we are going to use 1 for jump up, 2 for jump up and 3 for jump down. So 0, 1, 2, 3. Let's create our transitions. Jump up, move equal 2. The jump up, we go jump down with a move equal 3. From jump down, we go to stay if move is 0, and we go to walk if move is 1. And we do also this just in case. Should never happen, but better to set it to go back on stay. And all those items will have no exit time. So just me reset everything. They are sprite
Walk to jump.
Yes?
Walk to jump up.
We do jump up and jump down because we don't know how long we are jumping. So
Walk to jump up.
now walk to jump up. Yes, you're right. Let's do make transition. Jump up. Very good call. Yeah, I forgot this one. And this will be 2. Okay. Very good call.
Equal to 2.
Pretty cool.
Thank you for spotting all my errors. Okay, so let's go in the code, and in our game, when we are jumping, we'll also do anim set integer move with 2. And we are going to reset to 0 only if we are not jumping, because we don't want to stop the jump animation if we are not jumping. We are not yet calling the going down. We'll do it in a moment. So just play the game 1 second to see if the animation is okay. And yes, going up looks okay. Okay? But there is a small problem. Our animation should not loop. So jump down should not loop, and jump up should not loop. Let's see if now stays in the correct jump. Yes. But we want to switch if we are going down. We are just going to check the velocity for this. So if player rb.velocity y, we are going down, so we are less than 0, and is jumping. In this case, we do anim dot set integer move in 3. Let's see if it is working. And I think we got a very good jump animation. What do you think?
Can you start the game again?
Sure. Okay. Is okay?
Okay, okay.
I think there is an error here because I don't see this animation playing. Exit time is okay. If it is equal to, we do jump up. For some reason, I don't see this working, but that's okay. Okay, so we want to change, but we don't want to change the move if we are jumping. So here, if not is jumping, we change the animation. Let's try again. We walk, we jump, and yes, we don't do anymore the walk animation while in air. Okay, so next I would
One
say
question, simple.
ask.
Why is jump down animation not working when we start the game?
Because I'm not calling it. We can do it. We can do it because we can do. We start with is jumping true, and if we do this, it should work with the animation. No, probably I have to set it in the start to make it work. No, sure, because from starting, yeah, that's okay. I'll show you why it is not working, because when we start, the default is stay, okay? And we do not have something to go immediately to jump down.
Yes.
Okay, we can either say, okay, but we are always going starting from jump down and set this as default layer state, or we can create the change between stay and jump down. Let's just do this in this case just for simplicity, but it's better to create an explicit transition. Let's go back here, game. No, still not going down here. So no, for some reason is not working. So let's say let's just play jump down animation at the start. Let's do start. Anim play jump down, and we set move to 3. Okay, let's try if now it is working. For some reason seems to be not working. I really don't want to lose too much time on this minor problem, but let's try to fix it. Let's try again. Now, literally, it doesn't want to work on this subject. I don't know why. We can debug if you want, but probably will take forever.
You can leave it.
Yeah.
What's wrong?
For some reason, the jump down animation doesn't play when you are starting. I don't know why.
Because you're not checking for is this jump on else condition. Else if you should check it. I remember how we go to Visual Studio.
Yeah.
Strange.
Strange.
Else if not jumping.
Strange.
I mean,
It's really strange.
We could use from any state, I think.
Yeah, but I think it's let's do a last check here. So we do this here and this in parallel just to check what's going on here.
Okay.
Play and
Okay, it's state
because it stays on zero. Stay on zero. So for some reason this is set to 0. So move 0 is not as jumping, but this one should be jumping. Is it? This is on. Ah, of course. I set this on true here, but if I go on the game, is jumping is false. That was the problem.
Now it's work.
Yeah.
Now it's fixed.
Yeah, because it was a public item, so you had to change it inside the inspector. I didn't talk about this, but yes, that was the problem. Okay, so what about game over if we touch the water? Is that okay?
Yeah.
So let's create a canvas and just an image. Let's import Text Mesh Pro.
Just one quick question.
Yes.
How long it will go, the class? I mean this training?
This training?
Yeah.
At least another half an hour, but then we can continue a few minutes more if you want.
Okay, actually I need to leave.
We are recording the stream and will be published probably on YouTube.
Ah, that's great.
Yeah.
So I'll see the link. Are you going to put down in here somewhere in United Programming?
Yes, the link will be posted on the Discord server, sure. Probably tomorrow will be posted on YouTube. In a little bit of time will be posted.
Okay, that's good. Yeah, so have a good day.
You too. Bye, and thanks for joining.
Yep.
Okay, so let's make this bigger. Way bigger than this. Let's make it wider. Let's align to the center. Okay. Let's use the drop shadow maybe. Let's move it a little bit on the top. And game over, let's make it red. Okay, just a normal game over message on the screen. What we will do, we can remove event system, we are not going to use it right now. First we get a reference to this text inside our game. Public text mesh pro you guy game over. Okay, and in case this object is visible, we are not going to move. So if this one is enabled, we exit. We do not accept any movement here, and we do a public void game over function. Maybe this one is better if I use lowercase. And the only thing we do here is to enable this Text Mesh Pro. We are going to call this inside the player.
What on me?
What? Okay. We are checking this inside the player collision. In this case, we don't use a collider, we're going to use a trigger. but it's the same. Private void on trigger enter, and we check if order compare tag order. We do game over. Okay, we need to create the trigger for the water, but this is very easy. Just go on water, add component, box collider. Just be sure it is big enough. Okay. And let's set it as trigger, and let's create the tag for the water. A tag water, save, go back to the water and set the tag. That's it. Now, of course, we want this to be not visible by default, so just uncheck the text mesh pro. Let's play and try if it is working. We forgot to add the reference, my bad. Okay. Let's play again. Okay, we are walking, let's jump, let's fall in the water, and we got our game over. Easy enough, no?
Yeah.
Okay, so what about some enemies to place?
You can make them go up and down like in game, and when you shoot them, they will deactivate for a while.
Yes. First we have to create the enemy, and we're going to do it right now. Then we can add a simple AI to go up and down or left and right, something like this. And shooting, yes, we can do it, but we have to create the shooting animation, the bullet, and so on. We will see what we can do. So let's start. Create a folder. Let's call it enemy.
Are we going to do all of this today, or is it like going to be in?
We continue for another 30 minutes, but more or less, and if we cannot finish, we will continue another day.
Okay.
Okay, so let's go on the enemy. What will be an enemy? In the game there were some eyes. Let's just create a sphere for the enemy. Let's move it somewhere we can see. Okay. And we are going to add a material. Let me copy all the sprites I already created. This will be a 3D object. Let's create our material for the enemy. Enemy 1. This one. For this material I need the transparency. That is, we can try this one. Okay, looks acceptable. Okay, we got our sphere enemy here. Okay, let's also add a color to it. Don't remember if it is like this. Yes. Okay, so we got the exterior that I have to replicate for all the blinking, but we will do it in a while, in a second. we call it enemy, and we place another sphere inside for the pupil. So let's duplicate this, call it pupil. Let's make it a little bit smaller in our direction. Let's place it inside, and let's create a material. Create material pupil, and just use this albedo here, drag and drop, and we got our wonderful eye here. Now let's make it blink and look around very quickly. So to blink, we will just alter very quickly the the material. So let me duplicate this 4 times. 2, 3, 4, 5.
Aren't we going to do an animation?
No, we'll not do it with animation, because with animation it's difficult to make it random, while with 5 lines of code we can make it random. So enemy 2, okay, 3, 4, oops, 4 and 5. Okay, now let's create the enemy. Create script enemy, drag and drop over the enemy, and let's create the tag enemy. Okay, and let's edit this script. I will copy it from my script I already created the other day, and I will explain how it works. Enemy. So we get the materials to alternate and the mesh renderer for to change it. We have a couple of variables just to do some random delay, and a quaternion to rotate the object. First, if I go here and I change the rotation of the part inside, do you see? It will rotate the item, the actual pupil. If I change the materials, they are not very visible here, but you can see that this is some sort of animation to blink. And this code here, in case this timeout goes to 0, first we will set another random timeout, and then we are going to blend the, we are going to decide where to look. This is just doing some random rotation, and then blending with the lerp to the new rotation. Blink, we're just waiting some time, and when the timeout is gone, we are just transforming the timing in an index inside the materials that we're going to set, and we will just set the material to the object. Let me fill the materials here. There should be an error somewhere because I do not see, probably I did not save. Yes, Ctrl S. Okay, so renderer, drag and drop, pupil, drag and drop, eyelids, 1, 2, 3, 4, 5. Nice and easy. Let's play and let's see what's going on with this item. And looks not too bad. What do you think?
That's really good.
Okay.
The rest thing is to make them floating around.
Yeah, it's just a little bit of script. That's very easy script to do it. Let's now create a few of them. Just duplicate the objects and place them somewhere else. Oops, but I
This
don't want.
one got no material.
Yeah, I just dragged the interior part and not the exterior. Is my bad. Okay. Let's see. And of course, because they are random, they are all different. If we do it with an animation, they will probably play all the same animation. Is this point clear?
Yes.
Yes.
Okay. Now, they are good, they are nice, but first, they are not rotating. Second, they are not attached to the tower. So
They
let's
are also
attach.
creepy.
They are intentionally creepy. Let me create a. Let me place them inside the tower. Okay, so they will now rotate with the tower. Okay, but we need to also to place them correctly. So first, let's try our script as before. And what's going on? Distance, I would say, is okay. So is a good distance from the tower, you can see. But they are rotated not correctly. They should be rotated 90 degrees more. So let's go in our code for the tower editor. The rotation is here. The platforms were rotated correctly, but in case this item is an enemy, we should rotate 90 degrees more. How? Simply we do if item compare tag enemy, we do angle plus equal 90 degrees. Let's try now. Tower selected, click on align objects, and was the wrong direction. So this is less 90 degrees. Let's try again. Yeah, now they looks good. Okay, our creepy eyes are here. Another thing we want to do is, if we are colliding with them, we want to die. So let's do something simple right now. That is, in the player, if we are colliding with an enemy, what do we want to do here? We want to grab our collider. So get component collider. And for us, it's a sphere collider, but we do not really care the type. And we will disable. So we are going to fall. And we call the game over method. This will be enough to fall to the water. Let's have a look. Another thing, the enemies have a sphere collider, yes, but we want to remove this sphere collider from the pupil because we really don't need it. So select the pupils and remove this component. Enemies have the correct tag. Let's try. And if I'm touching this enemy, I go game over.
Nice.
Okay, let me move away this enemy right now because, oops, because I want to do another thing, that is making the camera to follow the player. So let's do some extra items here just to go up. Okay, let's call our magic button to have everything set correctly. And let's play a moment to understand the problem here. So, going here, okay, oops.
Jump on steroids.
Yeah, that's okay. I will just make it difficult to hit. What are you? So we're going here, I'm jumping, okay, I'm jumping, okay. Oh, I cannot go anymore. And probably there was an enemy just over this place. So what should we do? We should move the camera to follow more or less the player. We can do it in many times, in multiple different ways, but literally we need just one line of code to do this. Let me also remove a little bit the jump power, probably 5 is better, okay. And let's do our camera follow, that is one line of code. So first we get the reference to the camera, public transform cam, and here we do camera dot position equal math lerp, oh sorry, vector 3 lerp, my bad, vector 3 lerp, camera position, and we want to have more or less the same position of the player vertically. So vector 3 position equal player position, or let's do camera position, and we do position.y equal player rigid body for the position dot y plus 1, just to stay a little bit over it. And let's move it fast, 5 times a fifth of a second. Camera movement. And let's also say that we don't want that the camera goes never under 0. So if position y less than 0, we stay on 0. Let's go back to Unity. Let's add the camera and let's try the game again. What do you think? Is okay?
Cool. Yeah.
Yeah.
Very nice.
Wow. You also made a
Can you show the camera?
limit where the camera will not move or move.
Yes, yes, I put a limit on 0. Guys, I think for today can be enough. We will say another 5-10 minutes if you have questions, and next time we'll do, for example, the AI for the enemies, moving platforms, and so on. So if you have questions, just ask.
0 questions, at least for me.
No questions?
Yeah.
No, really.
If everybody muted, except the Batmilk, then no questions, I think. Well, probably can have a question.
No, I have not.
Okay, so ask.
No, I have not. I have not question.
Yeah, John had a question.
No, I
no?
didn't have any question.
Then I think is okay for today. We can continue
Yes.
next time with something
Yeah,
more.
yeah.
Yep.
Guys, thank you so much for joining the stream, and see you next time.
See
Bye.
you.
Thank
See you.
you.
Bye.
See you.
Bye.